Okay, the lesson on 7.5 is going to break into two parts. The first part is graphing square root functions, and then later on we're going to graph cube root functions. But a lot of it's going to be really similar. So first, I want you to think about graphs that have been shifted. And we haven't seen a parabola quite yet, but we have seen an absolute value graph. Now, what I want you to remember about when we did absolute value graphs, and the same thing applies to parabolas, is they had h's and k's in a general formula, and the vertex was at the point hk. So we can identify shifts of the vertex by just looking at the equation. So this example, for instance, had an x minus 2 in the parentheses, and then a minus 3 outside of the parentheses. And what that meant was this was shifted 2 units to the right, because inside the parentheses or the bars for absolute value always meant opposite, and then 3 units down. Well, the exact same thing is going to happen here on a square root graph. So the first thing I want you to notice is that this is what a square root graph looks like. It's kind of like if you're doing a side bend in gym class and you reach your arm over your head. The shifting is going to happen the same way. We have an h and a k, and our vertex is normally, our starting point is normally at 0, 0, but it's going to be shifted either right or left or up or down. So this example again was shifted right 2 units and down 3 units. So right 2 units and then down 3 units, and it looks exactly the same, it just was shifted. So let's talk about how these next few problems have been shifted. So the first example shows you x minus 1 inside the square root and then plus 2. Now remember, inside the radical or parentheses or the absolute value bars is always opposite. So when you see a minus 1, that really means right 1. And then the plus 2 on the outside means it's been shifted up 2. So using that for number 2, I think we've been shifted right 3 units, because it's always opposite inside by the x, but then down 2 units, because negative 2 is on the outside. Now remember, inside is always opposite, so x plus 4 really means left 4, and then the negative 3 is down 3. And then here, this is opposite, so it's left 2, and then plus 1 means up 1. So now we're going to translate that to the actual graph. So first thing I want you to do is we're going to come up with a little bit of a t-table. And I could use my calculator, but I'm actually going to use my old brain here. I can choose whatever x values I want, but because I'm going to have to take the square root of them, I'm going to choose numbers that are really easy for me to take the square root of. For instance, 0 is really nice, and 1 is really nice, and then the next number that's easy to take the square root of is a 4, and then maybe a 9. So I picked perfect squares. So if I were to plug in each one of these, the square root of 0 gives me a 0, square root of 1 is a 1, square root of 4 is a 2, and the square root of 9 is a 3. So let's go ahead and plot these points. And this does continue forever, but I ran out of room, so that's where I'm going to end. Now, bear with me as I try to graph this. You know it's hard for me to graph on the tablet. Woo, okay. It's supposed to look a lot smoother than this. Hopefully your graph looks better than mine. But it does have a definite beginning point right here at 0, 0, and then it stretches over to the right. You need to know that that's what a square root graph generally looks like. It could be shifted or reflected, but that's the shape. Now when I talk about domain, remember domain are all the x values and range are all the y values. So for this particular graph, the domain stretches from 0 to infinity. And it actually lands on 0, it exists at 0, but then it goes over to the right forever. Now the range is how low to how high. So again, he starts at 0 normally, and then he stretches to infinity. And as you can imagine, if this graph has been shifted, your domain and range are going to switch. So let's talk about how these values affect your graph. The first value I want to talk about in this equation is the a. The a is what we're going to call a vertical stretch. So if you have a number out in front of the radical, that is going to stretch or possibly even shrink, if it's less than 1, the square root graph. So it might make it rise 4 times as fast if there's a 4 in front of it. Now another note I want you to make is that if a is negative, just like with the absolute value graph, it's going to flip or reflect over the x-axis. And we'll see an example of that shortly. Now the H in this graph represents a horizontal shift. Horizontal meaning right or left. And then the K represents a vertical shift. And that means up or down. So remember, horizontal shifts are always opposite of what it seems because of that negative is part of the formula. But the vertical shift will be exactly what it looks like. A +3 means up 3. A -2 means down 2. So let's look at this first graph. And I know the mother graph, looks like a square root graph, just like we just graphed. But I want to talk about the shifting. I should notice here that the x plus 1 means this has shifted left 1, and then -3 means down 3. So the first thing I'm going to do is, instead of starting at 0, 0, I'm going to shift left 1 and then down 3. Now if I want to get some other good points, I can go to my calculator table and pick up some other good points, but I'm going to kind of cheat here because I'm in a bit of a hurry to get this lesson recorded, and I'm just going to kind of fudge in the graph like that. Now let me show you where to get points on your calculator real quick. I won't be doing this, but on your quiz and tests and homework, I do expect you to graph accurate points. So on your calculator, you're going to go to y equals, and you're going to type in the square root of x plus 1. After the plus 1, I want you to close the parentheses so it stops taking the square root, and then -3. And just for fun, let's look at the graph. Yeah, it does look like what I graphed. Now, if you go to second graph, which is your table, you're going to notice a whole bunch of values. And this would be something that you could look at to plot some good points. Now, I'm not going to plot the decimals because that doesn't seem like a good idea. I'm going to find all the nice points. So I'm going to plot 3, -1, and then I'm going to plot 8, 0. And unfortunately, I'm going to run out of nice points pretty quick. But as long as you have a few points plotted, that's fine. And you'll notice if you scroll negative in the list too far, it's going to start giving you errors. That's because this graph is not defined everywhere. He's got a starting point for his domain, and he doesn't go any further than that. So, as you can tell, I didn't graph too accurately, but hopefully you will on your homework and tests and quizzes. The domain, this time, started at -1, and then goes forever to the right. And then the range started at -3, and goes forever up. So there's your domain and range. Okay, the next example, I'm going to notice a couple of shifts. First thing I notice is it was shifted right 2, and then up 1, and then something kind of strange. There's a -3 out in front. What that means is we have a vertical stretch, this time of, I'm going to say -3. And remember, negatives take this and flip it upside down. So if you're not really sure what this looks like, I want you to go to your calculator, into y equals, and I want you to type this function in. So we type -3 square root x minus 2, close the parenthesis after the -2, so we stop the square root, and then +1. So you should notice he is definitely flipped. He's shifted right, and then the up 1 unit is a little difficult to see on this graph, but what I would want you to do at this point is go to your table or second graph and scroll until you stop getting errors. There we go. So let's plot the point 2, 1, and 3, -2. Yeah, let's pick one more. How about 6, -5. Alright, so again, forgive my graphs. Oh geez, that was pretty good actually. The domain on this graph starts at 2, so he goes from 2 to forever, or infinity. And then his range, this time you got to be careful. Remember, range is always lowest to highest. Well, he actually goes down forever. So his lowest range value is actually -infinity, and then he climbs up to a high point of 1. So the range on that graph is kind of backwards because he's been reflected. Alright, our next graph. It's going to have a 3 out in front again, x plus 2, and then a minus 1. So this has been shifted left 2, and then down 1, and it also has a vertical stretch of 3, so it's going to go up 3 times as fast. So instead of starting at 0, 0, he's been shifted left 2 and down 1, and just for the sake of time, I'm going to kind of fudge what this looks like. Something like that. He's been stretched by a factor of 3, so I might have underestimated how much he was stretched. If you go to your table, you type this in and go to your table, you're going to get some more accurate points. But the domain and range are going to be very easy to see. The domain stretches from -2 to infinity, and the range stretches from -1 to infinity. Okay, our next example has been shifted left 1 unit, up 3 units, and because he has a negative in front, he was reflected over the x-axis, so he's going to be flipped upside down. So instead of being at 0, 0, he was shifted left 1 and then up 3, and then instead of climbing up and to the right, he's actually going to climb down to the right. So again, I fudged the graph. If you want more accurate points, you're going to have to go to your table. The domain and range are going to be the same though, whether you graph it accurately or not. The domain stretches from -1 to infinity, and the range, be careful here, he actually climbs down forever, so his low point for range is -infinity, and then he climbs up to a +3 with a bracket. The domain and range are a little hard to see once they're flipped, so you really got to think about going least to greatest always for domain and range. And then this next section, I want you to identify the shifts of the graph. So the F is the original graph, and then the G is the shifted graph. So you're going to tell me whether it's been shifted right, left, up, down, or whether it's been reflected. So when I look at G for number 9, the 5 is original to the graph, so that's not different. But this +4 inside by the X means a left 4, and then this -3 outside means a down 3. So all you need you to do in this section is identify those shifts. This is really a square root graph. They just wrote it with a rational exponent instead of a radical. So the 3 has a vertical stretch. So this guy has a vertical stretch of 3. And then the -1 inside by the X means that it was shifted right 1. And then number 11, the square root graph is the original. So the negative means it was flipped or reflected across the x-axis. So you can say either flip or reflect. Reflected, I'm going to say, over x-axis. And then the x -3 means it was shifted right 3, and the +5 means it was shifted up 5. Okay, next we're going to talk about graphing cube root functions. Now, cube roots are very different from square roots because we can take cube roots of negative numbers. So when I think about numbers that are pretty to take cube roots of, numbers like 0, 1, and 8 come to mind. So I'm going to actually go to both positive and negative. So the cube root of -8 would be a -2. The cube root of a -1 would be a -1. Cube root of 0 would be 0. 1 would be 1. And 8 would be 2. So if I plot these points, 8, -2, and you could get all those points off of your calculator's table if you weren't feeling like thinking. -1, -1, 0, 0, 1, 1, and then 8, 2. So you'll notice that when you graph this, it kind of looks like a really stretched out S. And again, forgive my graph, they're never pretty. This is what the cube root function looks like. Hopefully yours looks a little better than mine. But what I love about the cube root function, its domain and range are so easy. The domain and range are always -infinity to infinity. No matter how it's shifted or reflected or stretched or shrunk, it's always going to have -infinity to infinity for domain and range. So you can get those right no matter what the problem is. So this graph normally has a middle toggle point at 0, 0. You'll notice right here at 0, 0. So that's what I'm going to plot first once I figure out the shifts. So here for number 12, this was shifted right 1 and up 2. So instead of starting at 0, 0, we're going to shift it right 1 and up 2. And then if you want to go to your calculator to get some other good points, that's fine. Again, I'm going to kind of cheat. Sorry, I'm a big cheater today. So it looks something like that. Your domain and range are always negative infinity to infinity. So that should never be a surprise. Now my graph does not look so hot. Hopefully you have some more accurate points, and on your homework or on your tests and quizzes, I do expect you to graph accurately. I'm just kind of rushing through this for the sake of time. Okay, this guy has been shifted left 4 units, but down 3 units. So instead of being at 0, 0, he was shifted left 4 and down 3. And no sort of reflection or stretch. So again, I'm kind of fudging the graph here. I even missed my point. That wasn't good. So I want you to graph more accurately on your homework. And graphing accurately just means going to your calculator and being able to type that in y equals and go to your table to get some good points. Very easy to do. Okay, this next graph wasn't shifted right or left any. He was shifted up 1 unit, and then this 2 in front means that we have a vertical stretch of 2. So he's going to be pulled up by a factor of 2. So instead of starting at 0, 0, he starts at up 1. And instead of being such a flat, stretched out S, he's going to kind of go up and down a little whoops, faster than normal. Goodness, hopefully your graph looks a whole lot better than mine. But no matter what the shift, your domain and range are always negative infinity to infinity. And then our last example, negative cube root of x plus 2 plus 4. This was shifted left 2 and then up 4. And then this negative out in front means it was reflected over the x-axis. So we're going to see this guy flip. So instead of being at 0, 0, we're going to go left 2 and up 4. And then instead of stretching like an S, he's going to have to be flipped. So, okay, missed my point. I pretend that's what it's supposed to look like. It's not that bad. And then again, domain and range are always negative infinity to infinity. Doesn't matter what happened to it. So at least that part's easy. That concludes the lesson on 7.5. We're going to continue solving some funky numbers next. So some funky sorts of solutions.